Bismillahirrahmanirrahim. Welcome to International Research Class. For this time, we will discuss about the generating daily rainfall parts 2. In the parts 1, we have discussed about the one methods to the generates or the simulates the daily rainfall. We need the data, the daily rainfall of the data. In the theoretical, we must divide data becomes two group. The first group only the zero data or the not rainfall data. And the second group is the rainfall data. So in the theoretical, when we are in the chapter or the part 1, we must find the probability null or probability 0. Sometimes the people say probability null, but sometimes people say probability 0. Probability 0, it means you must divide the number of the zero data divided by the whole number of data. That's it for the first graph. For the second graph, especially for the not zero data or the rainfall data, we must produce the parameter of gamma distribution, alpha and beta. And the all theoretical completes we discussed in the part 1. So if you are interested to learning about how the theoretical comes true, can join with the www.radoinstitute.com. Okay, find to the international research class tools. You can find the generating synthetic daily rainfall part 1. And then in the part 1, we have produced the best programming, how to use the R software to run the programming to produce the synthetics or the simulation rainfall. But in the part 1, we just limited only for the first one, or we are limited only for 1 month. So in this time, we will continue our study, our discuss to produce the R programming to complete for the all months. We have there is the 12 months in 1 year. So for this time, for the part 2, we will be produce the program for the 12 months. And then we try to produce the graph to comparison the two characteristic statistic, namely probability not rainfall and the mean rainfall. We will produce using this two characteristic. We will produce the graph of the two characteristic statistic for the synthetic rainfall and then for the observation rainfall. I mean the real data rainfall. We can check if the graph produced by the synthetic rainfall for the probability not rain and the mean rainfall same with the graph of the probability not rainfall and mean rainfall for the real data, we can say our mission is complete and will be best programming for the all months. Our discussing today still based on the nice research article. Well, we still based on this research article. generating synthetic rainfall on the various time scales, daily, monthly, and yearly. We are not talking about this theoretical again. We will continue to our programming. Okay, we stop share here and we are share our programming. Okay, this is our programming. Okay, you can check the programming. Start from this one, how to call the data, until this one we have discussed in the chapter 1 or in the part 1. We understand if you are forgets about the explanation about this programming, please join again in the www.radoinstitute.com. You can find the best explanation about this program. Okay, this is for the first month or the 4th January. We call this with the state observed 1. And then for the February or the 2nd month, we are use the same program, only we make different in this one only. We change by the number 2. It means we are only process in the 2nd month for the 100 times. And then we call the program state observed 2. And then for the 3rd month, we only change to become the 3rd number. Okay, number 3, I mean. It means is the 4 months only, and we are simulate until 100 times, and we give name by the start observed 3. And then we do it again until the 12th or December. We do it until December. This is December. We simulated until 100 times, and we give name the start observed. After this program we run, we must give the special name for the MC1. MC1 only for the output the program in the step observed 1. We do it until the MC12. MC12 is specially for the start observed 12. We give the name. And after that, we need the data only the 3rd column. We know the 3rd column for the 100 value of the probability not rainfall produced by the simulation. So it means there is the 100 value. So for the representative 100 value in the 3rd column, we use the name the maximum. Yeah, you use the name maximum. The maximum for the representative of the 100 value in the 3rd column. And then we need the PRS1. It means we need the probability net rain, not rainfall, from the real data. We have the 100 value, but the all value is same value. So just we need only for the representative only with one value, is the first line and the 2nd column. So we need the tools as numeric, because if we only use this programming, the program cannot run, because in this programming still have another variable. It means the name of variable. So we must cancel the name of variable using tools as numeric. So after that, we have the PRG for the simulated rainfall, for simulated probability not rainfall, PRG1 for the January until PRG12 for the December. And PRS, it means the real probability net rainfall for the January until the real not rainfall until the December. Okay. This is for the probability not rainfall. And how about for the mean rainfall? For the mean rainfall, we need name MRS1. MRS1, it's mean the mean rainfall from the observation data or the real data. This is for the fourth column because in the 100 simulation, the all same value for the observed mean rainfall, we representative by using the one value. So that's why we need the only the first line and the fourth column. So we cannot use this programming. We must give the name of as numeric because if we only use MR1, there is the name of the variable here. So we must cancel the number, the name of variable with using the name with using as numeric. Okay. So after that, we use the mean rainfall from the simulation in the in the fifth column, because we have the 100 value, the all value is different. So we must representative with the one value by using with the mean. Yeah. So this is for the mean rainfall January, okay, and until mean rainfall December. So after that, we have the mean rainfall for the simulation, and this one mean rainfall for the observed or the real data. Okay. After that, we run our program and we make plots. Okay. Let's run our program. Okay. The first one we call our data. Okay, data here we call our data. Hujan Pekanbaru, hujan our data. The name of the data, hujan Pekanbaru. Hujan Pekanbaru. This is our data. We check our data. Okay, we check our data. Okay, this is our data. Hujan Pekanbaru. We open our data. So we check on the console. For check the first data, we use the name heat data. Heat data. Okay, you can check here. We have the fourth column for the data, namely years, months, day, and our data rainfall. 0 is mean not rainfall. If not 0, it mean the rainfall. And the last data, to find the last data, you type tail data. You type tail data here, the tail data. And then you enter, and then you can check our data start in the 1990 until 2000X. If your data have the value of minus 99, it means the missing value. It means the missing value. Okay, after we have the data, we run our program. The whole program we run. Okay, we run our program. And then you can check in the console. Okay, you can check our program is running well. Okay, there are not the blue color. It means the whole program is very good and the whole program running well. So after we have the all that we need to produce the graph, we try to run our program to produce the graph. Okay, you can check our graph here. Okay. Okay, you can check. We have the two graphs. The first graph for the probability not rainfall observation for the red one, and the probability not rainfall simulation for the black one. And then this is for the mean rainfall. The red one, the mean rainfall observation, and in the black one, the mean rainfall simulation. We can check here. We are success for the each month for the mean rainfall simulation. I can say success because the each month or the 12 month, the mean rainfall, the produced by the generating synthetics or the simulation rainfall have the same value with the mean rainfall observation or the mean rainfall produced by the real data. You can check here. January, February, March, April until the December, the all mean rainfall from the simulation a very, very success to capture the real data. But it's different with the probability not rainfall. We only success only the January, March, April, and December. And the other months, we are not success. So from this one, for for example, we will discuss about the April data, April rainfall data. You can check here. In the April data, we are very success to produce the rainfall. We are success to generate daily rainfall for the April only because our mean rainfall from the synthetics data very, very close with the mean rainfall from the real data. And then for the probability not rain, we can see the probability not rainfall by using the synthetics data so very close with the real data. It means in the April, we have the same number of zero between the real data and the simulated data or the synthetics data rainfall. For example, if I have the 1,500 daily rainfall data in the April, if in this month, if the real data have the 1,000 zero data, it means we are success to produce the 1,000 data zero or not rainfall from the generating synthetics data. And then we have this very, very closely the mean rainfall in the April. So we can say that it's very perfect result. In the mean rainfall, we are success to very close. And then in the probability in the not rainfall is very close. But it's different with the X number, X months, or the August. In the August, so very, very, I think the very not, so I think it's not good here, but in the mean is so very close. So it means in the August rainfall, our simulated only produce the number of zero data smaller than the number zero data real data, the observation. We can check here the June until the November, we have the zero data for the synthetics rainfall or the simulation rainfall smaller than number of zero data from the real data. So that's why we are so very, very success to discuss for how to make the generate synthetic daily rainfall for the January, March, April, and December. But there is one chance to make the result will be better. Maybe we can use the other probability. We are not use gamma. Maybe we can change our distribution by Weibull, Beta, log normal, Nakagami, Sujata, or the other distribution. You can check and then you run our program. Same program, only just try to change the parameter only. Okay, this is our discussion for today. Nice discussion, I think. So if you are the students and then if you are the researchers, if you want to make the generating synthetic dairy rainfall, please you are join in the www.radoinstitute.com and then you can find the tools or menu international research class and then you can find the theoretical about the generating synthetic dairy rainfall part 1 and then you combine with this chapter or the part 2 you have the good power, you have the more knowledge how to make the best research, how to produce the generating synthetics daily rainfall. Okay, Rado Yendra International Research Class, Rado Institute. See you again.